Welcome back, Math Marvels. I'm Sarah Fuentes, your math specialist and your math coach, and we're back with Geometry 101 Lesson 2. Yesterday, we did a lot of work with rectangles and figuring out how to find its area and area of parallelograms. But today, we're going to use some of that information to figure out how to find the area of right triangles. So let's get ready. This is Lesson 2 of Geometry 101. Here's our big question for today. How can a rectangle help me find the area of a triangle? Aren't they two different shapes? And here are our learning targets. We're going to look for patterns and connections between triangles and rectangles, identify the base and height of any right triangle, and find the area of a right triangle using decomposition. So before we go into our big thinking question of today of how can rectangles help me find the area of triangles, try and draw what you already know about right triangles in your notes. Just make two predictions. You can either make a picture or you can write something down in the notes section that looks like this. Take about 15 seconds. Okay, we're gonna keep that in mind as we start for today. Oh, sometimes things that are new are so frustrating, and when we're starting a new topic, it can seem really hard. So as we're going through today's lesson, I'm going to try my very best to model what I'm thinking of so that you can get a sense of what types of ideas and questions I ask myself. And at the end of my model, I'm going to just give you the keys to success. 3 things that I want you to keep in mind that will help you be successful on this topic so that hopefully you'll say to yourself after more practice, that you feel successful and that you can do this. So just consider that's what's going to happen now. We're going to model some problems. I'm going to really think about some hotspots, and then I'm going to give you some success points so you can unlock the skill, and that will help you feel successful at the end. Before we switch from quads to triangles, meaning 4 sides to 3-sided polygons, we want to just take a step back and think about what makes a triangle, meaning the number of sides and angles. They have three sides, 3 angles, but also how to classify them, because each lesson is going to focus on a different type of triangle. We're not going to look at all 6 different types of triangles. We're really just going to look at 3 during our lessons. And today we're going to focus on right triangles. But I wanted to make sure you understood how we were looking at these. We could look at triangles and classify them by the number of sides they have. So if they have 3 equal sides, we will call them equilateral, meaning all 3 sides are the same. If they have 2 equal sides, we call them isosceles. They tend to look like a party hat, really high up on one point. The 2 sides are exactly the same. Or they could have 0 sides the same, and those are just scaling. We're not focusing on any of those during our lessons. That's more for Geometry 102 and 103. Instead, we're going to look at our triangles based on its angles, and we're going to use what we know about the angles to figure out its area. And in today's lesson, we're going to look at the right triangle, and we're going to look at those angles in particular because rectangles also have right angles. So here's our first hotspot. How can the base and heights of a triangle and a rectangle be the same, but the areas be different? And today, remember, we're going to talk about right triangles. So let's take a look at my first model to see how that works and how that's even possible that 2 shapes with the same dimensions can have completely different areas. What do we already know about right triangles? Well, I know it has 3 sides, that's a definite, but when we say right, we mean that it has a right angle. Not that it means it's turned to the right, it just means that it's 90 degrees. That's all. So let's think of what that actually means picture-wise. And you may have seen one of these tools. This is a protractor, and it helps us read angles. And it helps us make angles from, let's zoom in a little bit, from 0 degrees all the way to 180. That's actually called a straight angle. So we want to make an angle that goes from 0 all the way to 90. That means we could either go from this point, one line going this way, and it intersects with another line to make a 90-degree angle, or we can go the other way. Notice there's a 0 here. So I can have one line here intersect with another line, that makes a 90-degree angle. A lot of people just say it looks like an L, either going forward or backwards L. And people will usually make a shape of an L, that 90-degree angle, and draw a little box next to it to just show that those two lines are completely perpendicular. One goes straight up and one goes straight the other way. So you have a 90-degree. Okay. Also think about it if you were hammering a nail. If I'm working on a project and I have to hammer a nail, I want to make sure that I'm not going sideways. I want to make sure that I'm going straight down. So if this is my base, my other angle, my other line should be going vertically, completely straight and vertically to make 90 degrees. The other thing that's a little bit tricky about this is that when we think of these, let's move this guy over for a second. A lot of times people just think about the angle and they consider like, well, it always has to look this way, like a vertical line and a horizontal line. But that's not true. Let's look, I can rotate this angle and the two lines are still the same distance apart. I can make it go the other way too. I'm still rotating. They're still 90 degrees. So even as I rotate it, that square is still there. Doesn't matter, I'm moving it. So by 90 degrees, we know that it's two perpendicular lines, meaning one and another, and they cross exactly so that they're both, you actually can get two 90-degree angles. Well, what does this have to do with finding area of a triangle? Let's look at what we already know. We know that when we have a rectangle, we have a shape with lots of 90-degree angles. That's what makes it a rectangle and not just a parallelogram. We learned that in the last lesson. So how can I use what I know about rectangles to find the area of a right triangle, meaning another shape with another 90-degree angle? Well, let's start by trying to draw one. Let's zoom in. And imagine I'm drawing a rectangle with a base of 4 and a height of 3. Okay, so my base is 4 and my height is 3. There we go. And I'm going to try and think, what would the area be? And we know from our last section, here's my base, that the base is usually at the bottom. So I could have just rotated this and it can still stand up and that would be fine. But this part is my base because right now it's at the bottom, and my height has to be directly from my base straight up to the tallest point. So, and it's always straight up and making a 90-degree angle. That's what the height actually is. In this case, I can just clearly see that my area, my square units are the squares inside. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 units squared. And we knew that my area was just my base times my height. So I could see that it was just 3 times 4. Well, let's be really careful. 4 times 3, even though it doesn't matter, I want to be consistent with my base and height. So I have 12 square units. And I could also see in my shape that I have tons of right angles. I have one here, one here, one here. Here I have all 4. Every angle there is a right angle. That's what makes it a rectangle. It's a perfect right angles everywhere. But how does this help me with right triangles? So let's say I have a right triangle and I'm going to give it the same dimensions as my rectangle. And I'm going to kind of draw them right underneath on the other one. So let's say I'm going to do the same thing. So it has a base of 4. 1, 2, 3, 4. And a height of 3. Okay, exactly the same. Height 3, base 4. But do these have the same area? It doesn't look like it. It looks like I have much more space inside here than here. Matter of fact, when I look at it, do you see it? Wait, let me do that again. Do you see the triangle in here? They have the same area. So if I just take a rectangle and split it in half, I have 2 right triangles with the same base and height of 3 and 4. So I'm going to actually draw that into my figure and tell me what you think here. Here, I'm going to draw it in there. Oops. There. Now you can see it. I'm going to just draw it one more time. So do you notice that if I cut this in half and I have half a rectangle, that my area must also be half of that? So this is why we say for triangles, for right triangles, my area is the base and height. I can find the whole rectangle. 4 times 3. But then I have to take this number and cut it in half or divide it by 2. So my area is 6 square units. And that makes sense because I can see 1, 2, 3 whole ones. But then I have pieces that come together like these. This little piece probably comes together with these pieces here to make another one. So it looks like I almost have 1, 2, 3, 4, but this is missing a piece there. And then these two would make another piece in there. But it's exactly half. And this is why I can have a rectangle and a triangle with the same base and heights, but my areas are different. All right, so what about this second hotspot? Why do we sometimes see division written as a fraction? That just seems really confusing. Time for another hotspot. And this time it's writing our division as a fraction. So we already talked about how for right triangles, we're looking at the base and the height and then dividing it by 2. We're going to multiply those two numbers first. But I could also write it another way. Now that we're getting older, we can see division written as a fraction. And even when we think of a division sign, this is actually a fraction in hiding. It's just my numerator and my denominator, one number being divided by another, except instead of these symbols, these numbers or letters, I just have 2 dots. But it's the same. Fraction bar is just another way of showing a division symbol. So don't be scared if you start to see this formula. It still means the same thing. It still means base and height, then divided by 2. Because these two are together on top, that means I have to do this part has to be done first, and then we can divide by 2. So let's not get nervous if we see that with some of our work for today. Here's our last hotspot. What if I have a triangle that has fractional edges? This one can be really stressful. Fractions and geometry. I haven't done fractions in so long. No worries, I got you covered. Just watch how I go through this problem. Okay, we're up to our last hotspot. And what if we have a triangle, a right triangle that has a fractional edge? That means that the sides may have fractions in it. So let's start by drawing our right triangle. I'm going to put my little angle in there so I can see where my sides are. And I'm going to start with, let's see, this one's going to have 3 1/4 inches here and 2 1/2 inches on this side. And remember, for what we've been doing so far, we know that we have the area of a triangle, which is a base and the height, being divided by 2. So we're going to look at 2 steps. I'm giving myself tons of room here. Remember, I'm actually going to put another side here. Let's say this was just 4 1/2. I'm putting that side there even though I know that that's not a side we need. We need a base and we need a height. And the height has to be perpendicular. It has to make a right angle. So I know that these are the 2 I actually need, and I don't need this number at all. But we're going to start with our first step. And that means we're going to find the area of the whole rectangle by multiplying the base and the height. And remember, we talked about that because when we multiply base times height, we get an area of this entire shape. And we want that number first. So let's start by just putting those numbers in there. My base is 3 1/4. And my height is 2 1/2. And when I have these numbers, I want to turn these fractions into mixed numbers. And I'm sorry, these mixed numbers into an improper fraction. And if you're stuck on how to do this, we did this in another unit, so you may just need some refresher. But we're gonna go clockwise. Starting from the denominator, we're gonna move in a clockwise, moving the same direction as the clock. So my denominator is gonna stay the same. It's gonna be a 4. But watch how I'm going to move this way. I'm going to multiply these two numbers and I'm going to add this one over here. That's going to be my first step. I'm going to multiply 3 times 4 to make 12. And then I'm going to add 1 to get 13. And we're going to do the same thing with the other side. We're going to go clockwise. We're going to start by multiplying 2 times 2 and then adding 1 to get 5. And then my last step, I'm going to just multiply my numerators and my denominators. Just denominator, denominator, numerator times numerator. So I'm going to get 65 over 8. So that's going to tell me the area of this entire rectangle, but I want to only get half of it. So what's my next step? We're going to half it. We're going to divide it by 2. So let me get some room over here. Step 2, and I'm gonna divide by 2. I want to change. I know as soon as I see 65 over 8, I want to turn it into a mixed number, but because we had to divide, it makes sense to just keep it. And then we're going to divide it by 2 over 1. And again, if you don't remember this step from before, we're going to do keep, change, flip. We're going to keep this number the way it is. We're going to change this to multiplication, and we're going to take these two numbers and we're going to flip them to the reciprocal. We're going to flip them around. So keep, change, flip. All right, so we keep the first one. We're going to change this to multiplication, and instead of 2 over 1, we're going to flip it to the reciprocal, 1/2. And now when I multiply, I'm getting 65 over 16. To change this back into a mixed number, remember I'm just doing division again because I can see my division bar is hiding right there. And I'm going to do 65 divided by 16. And I know that 16 goes into 65 4 times, because 16 times 4 is 64. And that leaves me a remainder of 1. So 1/16. And my final answer is 4 1/16 square inches. So I know it looks like a lot of work, but just remember, it just means you have to remember your multiplication facts for fractions, meaning I'm going to change these mixed numbers to an improper fraction, and we're going to use our clockwise. Whoops. We're going to multiply and add. And then for our second step, we're going to use keep, change, flip to actually do the division work. And then our last step, we're going to change any fraction back into a mixed number using division. So yes, it looks like a lot, but a lot of things in math can seem really overwhelming when we think of it as a lot. So you're going to chunk it into these smaller pieces. Here's our step 1, here's our step 2, and finally here's our answer. And that is how we find the area of right triangles, even when they look like ugly fractions. You can do this. We're just going to take it step by step in smaller pieces. Okay, math marbles, now you saw all the models, so let's make sure that you can unlock the skill with our keys to success. That way we know we can get it right every time. So we're gonna focus our mind on doing these 3 things. Number 1, we have to identify the base and the height of the right triangle. And we're gonna use the right angle to do that. Those are the 2 angles that are always surrounding that right angle. So when you see that little square, it's those 2 sides that are touching each other. That's the base and the height. Even if I rotate it around, that's why it's a good tip. Second, strong habits make us more successful. Meaning, write down the formula for area and triangle every single time. Base times height divided by 2, and then substitute. Even if it has an ugly fraction in it, we get into a habit of writing it down as a plan, and then we're gonna slowly chunk it into smaller pieces. And third, we're gonna remember to create improper fractions before multiplying when we have fractional edges. We have to do that first so our numbers don't get confusing. If you can remember these 3 points, you're gonna do a great job on these problems. Don't be surprised if it takes practice. Everything we do for the first time is going to feel uneasy and uncomfortable. And that's fine. It just means we have to practice it so it becomes more normal for us. So don't get frustrated if it seems hard at first. It is new. Everything you know how to do right now was something you had to learn. And this is no different. So these are our skills. Keep them in your mind while you're working through these problems. So before you go to practice, remember you need to find the base and the height for a right triangle. So look for your 90-degree angle, and that's the easy one to find. And then you're going to use the two sides that surround it, that hug that angle together. Those two are going to be your base and your height, your base and your height. Even if we get tricky and turn that triangle upside down, you're still smart enough to recognize here's your right angle. So these are still the two dimensions that you need, your base and your height. You just have to flip it around. This was a really long lesson, especially compared to yesterday. But take your time, take your notes, and remember, you really have this math marbles. It'll take practice, but it's not how you start, it's how you finish. So take your time with your notes and your practice, and I'll see you next time for another math mini lesson.